Hello, I'm Dr. Zyata here. This video tutorial is solution to problem 4 by 3 from Engineering Mechanics Statics 9th edition. Statement of the problem is determine the forces in member CG and GH of symmetrically loaded truss. So it's a symmetrically loaded truss and need to find member forces in CG, that is a member CG, and then the other one is GH. As we have to just find two member forces, the best way to solve this problem is using method of sections. So these are the steps to find member forces in method of sections. So the first one is need to plan a cut, a section. So that is choose an imaginary cut that pass through the target members and less than 3 unknown member forces. And the cut must separate the truss into two stable parts. So one side can be treated as free body diagram. So the cut passing through target member, which are CG and GH, that should be something about that perpendicular to CD and then GH. So the possible cut is somewhere there. So like this cut is going to pass through CG and GH. The next one is next step, find support reaction if needed. So in this one, because we need to find sports reaction, so at both sports, so that is needed. So the next step, I'm going to find sports reaction. As is a symmetrically loaded truss, so for a symmetrically loaded truss, when uh, so that is a symmetrically loaded truss, and then for symmetrically loaded truss, vertical reaction at two symmetric supports are equal. Each is equal to half of the total vertical load. So reaction at left support is equal to reaction at right support, and it is equal to half into sum of total vertical load. So there are three loads which are acting in the downward direction. So reactions will be upward, and those reaction at both supports will be equal to each other, and they are equal to the sum of total vertical loads. Horizontal reactions are zero if there are no horizontal loads. So there are no horizontal loads, so horizontal reactions are zero because the support reaction lines are vertical, pin and roller on a horizontal base. So both pin support and roller support are on horizontal base. So at pin support there will be no horizontal reaction, so only vertical reactions are there. So then I can simply write there one as, let's say, a y, and the other one is a f y. So both are these, they are equal to half of total load. So in this case, ay is equal to fy, and that is equal to l by 2 plus l plus l plus l by 2. So that is 3l. So half into 3l. So both are 3 by 2l. Because all the loads are acting vertically downward, so reactions they will act vertically upward. So then the answers are like ay is 3 by 2l upwards, and then fy is 3 by 2l in upwards direction. So reactions are determined for symmetrical member. Next step is to choose a simpler side of the cut with fewer loads and fewer unknowns. So now if I'm going to consider right side of the cut, and on the right side, so there are two known loads and one reaction, and on left side there are again two loads and one reaction. So both uh, sides, so they are similar. Okay, so because both have same loads and reactions, but an unknown, so basically unknowns on the both sides are 3. Okay, and need to draw its free body diagram. So now we need to draw free body diagram of either left section or right section. So I'm going to draw free body diagram of right section. So that is a free body diagram of the right part. On the right part, there is one load at G, then one load at F, and then there is a reaction Fy, which is equal to 3 by 2L, and then show all external loads reaction on this side and represent unknown cut member forces assuming tension. And I have assumed 1, 2, 3 cut member forces as tension. And then need to apply equilibrium to the cut part to find unknown. So we have to apply for method of sections, we need to apply sigma m first and choose a moment point that has most unknown. So one point is D that has one unknown and the other point is G that has two unknown. So then I'm going to apply here sigma m about G equal to 0. So when I'm going to apply sigma m about G is equal to 0, so here these are two loads being one load and one reaction acting at point F. So the resultant will be upward, and that is L, because 3 by 2L is acting upward, L by 2 is acting downward. So the resultant will be L, which is going to act upward at F. So now need to find sigma m about point G. So sigma m about point G, so that is a G, and then the distance from G to D is distance from C to H is 3 meter or G to D is 3 meter. So that is 3 meter, and that is a line of action of CD, and line of action of CD, okay, so its perpendicular distance from point G is 3, and CG is going to produce moment in anti-clockwise direction. Then here at point F, the line of action of F is actually EF, and the distance from EF, perpendicular distance from EF to G is 3 meter. So that one L load is actually acting here and is trying to rotate it in anti-clockwise direction, counterclockwise direction. So assuming that counterclockwise direction is positive, so the moment is plus for the first one CD times by 3 plus L times by 3 is equal to 0. So CD is equal to minus L after simplifying it. And then I can apply sigma fx equal to 0 or sigma fy equal to 0. And for that purpose, I need to use sigma fx equal to 0 and sigma fy equal to 0 to find remaining unknown. And I have mentioned here resolve inclined member into components if needed. So need to find angle of CG with horizontal. So instead of angle, I am going to use dimension of the triangle, and in that triangle like CG, so I can draw a right angle triangle with 3 as its vertical distance and then 4 as its horizontal distance. The diagonal will be 5. Okay, so then I can resolve CG into its component. So one component is going there, that is CGX, and the other component is going towards the left, which is CGY. Next, I can apply either sigma Fy equal to 0 or sigma Fx equal to 0. And I can see that when I talk about components, so then there is only one unknown component in vertical direction. So I'll go for sigma Fy equal to 0 here. And for sigma Fy equal to 0, so then CGX is acting vertically upward. So CG is positive, and then the other two uh, load at G is acting vertically downward, so that is minus L, and resultant load at F is acting vertically upward, so that is plus L equal to 0. Now CGX, the horizontal component, using that triangular ratios of the triangle, so Fx is equal to F times X over Z, so it's CG times by X is 4 over 5, and both are going to cancel, so that is 0. So CG comes as 0. And next one, I'll apply that sigma Fx equal to 0. So for sigma Fx equal to 0, so first CGY is acting in negative y-axis. Next, GH is acting in negative y-axis, and then CD is also acting in negative y-axis. Now I have already CG as 0, so it is minus CG times by 3 over 5, and then minus GH, and I have CD there minus L, so that is minus into minus L equal to 0. So after substituting that CG equal to 0, so that whole factor is going to 0. So minus GH plus L is equal to 0. So GH is equal to plus L. So now required is, in this question, the required is GH and then CG. And then after finding unknown, need to do the interpretation of the signs. A positive value indicate tension and a negative value indicate compression. So now GH is positive, so then GH is equal to L, and that is in tension. Okay, so L in tension, because there is no unit of L specified here, so then L in tension. And the other one is CG, so that CG is equal to 0, and that is just a reference how to find components. So that is all done. So CG is equal to 0, and then GH is equal to L with our whatever are the units, because it's no unit, and then intention. So that is whole of that question 4 by 30 is solved. Thank you very much for watching.